Hello students, welcome to Hari Chemistry. So myself Dr. Hari Prasad. So today lecture students we will discuss a complete lecture on ethers on reaction with HI student. This is the very important topic for JEE Mains as well as NEET examination point of view or also for board also. This is very important reaction student. Maximum I will cover all the model of reaction with HI. Then you will get the perfect knowledge regarding this ethers on reaction with the HI student, right? Okay. Now we will start the lecture student. Before starting student, so if you are watching my video first time student, so please subscribe my channel and like the video and share to your friends. Those people are preparing for NEET and IIT student. It will help you a lot. Okay. Now we will do reaction student. Okay. Now ethers on reaction with HI student. Generally ether is a base student because of oxygen is having a lone pair, and this cleavage of ether on reaction with the strong acid, right? Okay, this is the strong acid. So now generally here student, this reaction is a acid base type of reaction. It is a acid base type of reaction. Then what is happening student, right? Generally look at student, this is HI, right? The oxygen is having the lone pair, so undergoing protonation of oxygen. So then student, here we will get the product of R dash OH, then oxygen will get positive charge. So this is protonation of oxygen. This is the step 1 reaction, protonation of oxygen. So generally it is a simple acid base reaction. It is a simple acid base reaction. Okay. So then look at student, so this is our I minus, right? So generally the next step reaction student, this is the first step is the protonation of oxygen, so we can call it is a step 1 reaction student, right? Now then the step 2 reaction student, right? This step 2 reaction is cleavage of CO bond student, right? Okay, so CO bond breaking and Ci bond making. So this is bond forming, Ci bond forming and CO bond cleavage, right? Now look at student, so generally here we have an unsymmetrical ether, so R and R dash will be different, right? Okay, now look at student, this type of cases, if you have an unsymmetrical ether, point is very important student. If our ether is unsymmetrical student, right, our ether is unsymmetrical, right? If unsymmetrical will be present student, this I minus will attack less hindered side, right? Less hindered side, I minus will attack less hindered side, right? Less hindered side, right? For example, if R dash is a bulkier group, then I minus will attack R. For example, if R is bulkier, then I minus will attack R dash only. So if R dash is a bulkier, then you write. For example, if it is a symmetrical ether, then I minus can attack anywhere, right? So you will get the same product only, right? Now for example, if we are assuming this R dash will be the bulkier group, now look at student, the CO bond breaking takes place, right? Now this bond will cleavage and this bond will cleavage and this I minus will attack student, right? So now look at student, so we will get the product RI plus R dash OH, right? Now in this process student, the second step reaction is very important student. This second step reaction is proceed through either SN1 or SN2. This is the most important point student, right? The second step reaction proceed through either SN1 or SN2, right? Okay. Now the question will come, sir, when will it will undergo SN2 mechanism and when it will undergo SN1 mechanism, right? Now look at student, if any tertiary ether type of compound will be there or any benzylic carbon will be present, these specific condition, it follows the SN1 mechanism. The remaining other cases student, it follows the SN2 mechanism only, right? Okay, the reaction proceed through either SN1 or SN2, that is depending upon your substrate, right? The reaction will follow either SN1 or SN2, that is depends on substrate, right? That is depends on substrate, right? That is depend on substrate. That will be depends on student substrate, right? So look at student, the step 1 is what? Protonation of oxygen, CO, right? Then second step is what? CO bond cleavage, and bond formation of Ci bond takes place, right? Now, two conditions you remember, student. If we have a symmetrical ether, I minus will attack this side or this side, no controversy. If unsymmetrical will be present, student, look at that, where less hindered side is there, then I minus will attack. This point is very, very important, right? Now, this second step reaction, student, that I minus proceed through either SN1 or SN2, right? Okay, this SN1 and SN2 reaction pathway decided by your substrate, right? Conditions we have very clear, student. If you have a benzylic position, you have a benzylic carbon is present, then it will follow the SN1 mechanism. Your ether will be any tertiary carbon present there, student, you can follow the SN1 mechanism. The remaining other cases, student, just you can follow the SN2 mechanism only, right? So this is about, student, formation of reaction ether with HI, student, right? Now we will practice some questions, student, right? Now look at, student. Now first of all we will decide this is the symmetrical ether or unsymmetrical ether, right? Obviously it is methyl and ethyl, student, it is the unsymmetrical ether, right? This is very clear, unsymmetrical ether, right? Very simple, student. This is H plus and I minus. Step 1 will be what, student? So now it is undergoing oxygen, right? Protonation of oxygen. Protonation of oxygen. Oxygen will get positive charge, right? Now, right now here, student, I minus is present, right? Now, I minus have two possibilities. I minus will attack this side, then ethyl alcohol is the product. I minus will attack, methyl alcohol is the product, right? Generally, student, here compared to methyl and ethyl, so methyl is the less hindered side, student, then I minus will attack here and this bond will be break, student. Here bond, CO bond breaking and Ci bond making place, right? So now, student, your product will be methyl iodide plus ethyl alcohol is the product, right? Now look at, student. Now look at, student, we have a 3 degree carbocation. Now look at, student, I will write this is R and R dash we have, right? Same reaction, student. The step 1 process is what? Protonation of oxygen, right? Now you will get, student, R and this will be protonation of oxygen, right? Now, so now look at, student, the I minus will attack. That is depends on our substrate. So usually, student, we have a 3 degree carbocation. So here, student, it is followed by the SN2 mechanism. But these particular conditions, student, it will follow SN1 mechanism, student. Then it will form a stable carbocation. When it leaves alcohol as, then this carbocation will get positive charge, student. Now look at, student, this will be R carbocation. Then our byproduct will be, student, R dash OH, right? Only simple, student, this is a blind process. If 3 degree carbocation is present, you can go through the blindly SN1 process, student. Now this is our carbocation. Now, student, this I minus will attack carbocation and you will get, student, so this will be R3 Ci is the major product, right? So generally in the option is given, this will be OH and R dash I is given, student, right? This tertiary cases, student, SN2 reaction is not possible, student. Generally it will follows SN1 mechanism only. This point you can remember, student. Tertiary is present followed by the SN1 mechanism. The remaining other cases simply you can follow the SN2 mechanism. If benzylic position is there, you can follow SN1 mechanism only, right? Now we will do some questions, student, right? Now look at, student, so this is anisole, right? Now look at, student, the step 1 process is very simple, student, right? Now look at, student, now this will be, you will get, this is, right? Now this will be OCH3, right? Now I minus is attacks, right? So now look at, student, this position is not possible to break, student. This will get, so this is phenyl cation, so then it will be highly unstable. That's why you look at, student, this bond will cleave and this bond formation will takes place, student. Now our product will be phenol plus methyl iodide is the possible product, right? Now look at, student, so this is, we can call it as a symmetrical ether. It is a symmetrical ether, right? It is a symmetrical ether, right? Now step 1, student, this will be C2H5O C2, sorry, this will be C2H5. So step 1 will be what, student? Protonation of oxygen, right? Then I minus will attack. If this bond will be cleavage, I minus will attack, ethyl iodide is the possible product R. If this side it will break, then I minus will attack this side. So anyway you are getting student ethyl alcohol and ethyl iodide is the possible product, right? Now right, you will get student C2H5I plus C2H5OH is the possible product. I hope my point is very clear. And one more thing student, sometimes maybe in examiner given as excess of HI, right? So HI is given as a excess, right? So if I am adding excess of HI, now then what will happen student? Again oxygen is having lone pair, now it is undergoing protonation, then you will get student, so this is OH plus student, right? Now this is a very good living group student, then I minus will attack, and so finally you will get student C2H5I is the possible product, right? Okay, now look at the student, examiner is given as excess of HI or 2 equivalents of HI, not given 2 equivalents of HI, not given excess of HI, simply given HI student, you can go for the single step process only student, right? Now look at student, so now if we have this type of compound student, right? Now CH2 double bond CHOH, right? This type of reactions are also very important student. Now look at student, oxygen is having the lone pair, right? Now look at, so our product will be CH2 double bond CH. Now this is undergoing protonation of oxygen student, right? Now look at, okay na, right? Now I minus will attack. So I minus has two possibilities. One possibility, this will cleave here, right? Generally if I minus will attack student, this will be SN, right? SN2 is not possible student. Why? Because here this is what vinylic, right, vinylic position student. Here double bond character is possible, partial double bond character is developed student. That's why I minus will attack here. It is very tough task student, right? So that's why the formation of this bond cleavage like this student, then I minus will attack here, right? Now look at student, we will get the product here CH2 double bond CHOH it will form, and one more is student methyl iodide is the product, right? Now look at student, this is simply I can call it is a vinyl alcohol only, right? Now this vinyl alcohol student, vinyl alcohol undergoes generally it undergoes student tautomerization, right? So tautomerization student, then it will give the major product to student, aldehyde is the possible major product, right? Now if vinyl ethers are present student, this vinyl ethers are formed as what student? Aldehyde or ketone is the possible product, right? So this reaction is very important student, just you can practice student, right? Now look at student, I cannot add this side student because of SN2 is not possible student, right? Now this side only possible, right? Okay, right? So this point is very important, you can revise. Why sir, why you are not adding I minus here? Because of student partial double bond character is developed here, so that's why I minus attacking here, it is tough only. So that's why this I minus will attack, it form as alcohol, and I minus attack will methyl side only, right? Now look at student, here also one more important reaction, you check it student, right? Now right, now look at student, so this will attack here, now this will be OH student, so protonation of oxygen, this is the tertiary butyl group, right? Now look at student, I minus will attack, right? Simple student, this bond breaking is not possible student, so this will be phenyl carboniamine is highly unstable, so that's why this bond will be shift and this will attack here student, right? Then automatically it will form a carbocation, then it is followed by the SN1 mechanism only, then you will get student, so tertiary butyl iodide plus product is student phenol is the possible product, right? Now here it is followed student SN1 type of mechanism, right? Now look at student, now look at, this is the benzylic position is present. Simple student, if tertiary is present, benzylic is present student, you can go through the answer directly as per the SN1 mechanism only, right? Now look at student, now look at, so this is here we have CH2, now first it will form protonation of oxygen, right? Then I minus will attack student. So step 2 process is what student? I minus attack, right? CO bond breaking and right. Now, so generally here possibilities are two possibilities. Sir, we can break this side and I minus will attack. We can break this side, right? But if we are breaking this side, student, it is a benzyl carbocation is formed. This will followed by the majority SN1 mechanism only. Now this I minus will attack and you will get, student, benzyl iodide is the major product. CH2I and methyl alcohol is the product. This is followed by the SN. So you can do the SN2 process, student. Simply you can break and I minus, right? But majority will be, student, SN1 is the most prefer for benzylic position, student, right? Next. Now look at, students, O18 is given. So this is the anisole, right? Now look at, student, the question is the O18 will be present here, phenol side or alcohol side is the question mark, right? Now first we will do the reaction, student. Excess is HI is given, right? Now excess is HI is given, once we will check, student, right? Right. Now look at, so step 1 process will be what? This is the formation of oxone, right? Right? Protonation of oxygen, right? Now this I will keep as, right? Now look at, student. Then I minus is attacks, right? Now if I minus is attack, student, this I cannot do, student, right? Because this will be, SN2 will be highly restricted because of SN2 is not possible here, right? Now I have only one option, student. Then I will shift this bond here. Then I will break the bond CO here only, right? Then I will get the O18 this side only. Then I minus will attack here and I will get, student, this will be OH plus CH3I, student, right? Now again I am adding 1 mole HI, student, because I have excess only, right? Again, student, so this possible, right? Generally step 1 is possible, right? Now you will get, student, this step 1 is possible, right? This step 1 is possible. Then so I minus step is not possible, student, because it will form, this will be phenyl carbocation. So right, this will be highly unstable, then further reaction is not possible. From this case, maybe examiner want to make a question, a number of equivalents of HI is possible, student. You can go with the answer, student. The number of equivalents of HI, that answer will be 1 only, right? Don't go for the answer 2, student, right? Because we are not, right? The second reaction is not feasible, student. That's why please you can concentrate, right? Now look at, student. So this is diphenyl ether, student. So simply you can go with the answer, student, anywhere, right? Okay, this reaction is possible, student. Now again this I minus attacking this side or this side. So this reaction is, student, this particular condition, it is not feasible, right? Not possible. This reaction is, student, not possible. Diphenyl ether case, student, we cannot get the reaction, student, right? Now look at, student. Now this question is asking the number of HI are required is asking. How many HIs are required is asking. In this particular case, student, if you look at, student, for example, if I form this is, student, right? OH plus, right? Now step 1 is okay, right? Now here I minus is present, student, right? If I want to break, student, right? Now here this will be SN2 is not possible, right? Now similarly SN1 also not possible. Both SN2, SN1, SN2 is not possible, this reaction, student, because of formation of, so pH plus, it is a highly unstable, right? Okay, now look at, student, is asking number of moles of HI is asking, right? Okay, now look at, student. So step 1 reaction we will do, student. First we will use 1 equivalent, right? Now it will form protonation of oxygen, right? Now you will get, this is OH. Now I minus will attack, student. This is the leaving group, I minus will attack, and so you will get, student, so this will be CH2I. Okay, now I used 1 mole of HI. Now again, student, again this will react with 1 mole of HI. So same process, student, right? Now you will get, student, this will be I and this will be OH2 plus, right? Again I minus will come, student, right? Then it is followed by the SN2 mechanism, right? Followed by the SN2 mechanism, followed by the SN2 mechanism, and so you will get, student, CH2I and CH2I. So right, now number of moles of HI is required, student. 2 moles of HI required for this particular case, student, right? Right? Now clear, student? Because here I converted, so first I used 1 HI, right? Then first I used 1 HI, then I minus will attack, right? Here I used, right, HI. So here I used 2 HI for this reaction, student. This is 1 HI and this is another HI, right? So the number of HI is required, student, 2 HIs are required, student, for this particular compound. Now look at, student. And one more very important, student, this is also, we cannot go for that, right? Now one more also possible, student, right? Now for example, this 2 iodines are there, student. Generally it undergoing, so minus I2, student, right? Elimination process takes place. Then you will get, student, CH2 double bond CH2, right? Now look at, student, again HI will react and we will get, student, so CH3 CH2 I also possible, student, because I am giving HI. So like, student, here, so the number of HI required, student, 3 possible, student. So please write the given option may be 2 HI given, 3 HI is given, 1 HI given. So don't go for the answer 2 HI, student, because of this 2 iodines, vicinal iodines are there, student. Generally it is unstable only. This unstable form, it will lose simply iodine, then one will leave and one will form as a double bond, student. Then again one more HI is required for the formation of ethyl iodate, student, right? So this is also most important, student. So just practice, student, right? The number of moles of HI required, student, 3 moles of HI is required, student, right? Now look at, student. So this is also one more important question, student, right? Now look at, so he is asking number of moles of HI is required for this particular reaction, right? So we will go for the first reaction, student. Simply I will use HI, student, right? Now I will get, this will be protonation, student, right? Now this will be protonation of oxygen, okay, na? Right? Now I will get, student, this will be CH3. This reaction I will do the next step, right? Now this I minus will attack, student, right? So this I minus will attack. So hopefully this will be leave this side and this I minus will attack, student, right? Now I will get the product CH3I, this is one, student. Then I will get the product CH2OH and CH2OCH3. Then again I need 1 mole HI, student. 1 mole HI. So same, student. So general reaction here I am giving. So this will be CH2, this will be oxonium ion, right? This will be H and this will be CH2OCH3, right? Now look at, student. I minus is present, student, right? Now this I minus will attack here. Now it is leaving. Now this I minus will attack, right? Now look at, student. So what possible product you are expecting, student? So here I am expecting CH2I, right? Now look at, so for this process, how many HIs are required, student? So we need 2 HI. So this is 1 HI and this is another HI, right? Now same, student, for this also here I am using 2 HIs, right? Now finally I will get, student, same process. Now I will get, student, so CH2I and CH2I. Now I used 4 HI, student, right? Now this is unstable only. This is unstable only. Now it undergoing reaction, student. It will lose I2, then it will form, student, CH2 double bond CH2. Okay, now, right? Now again reaction with HI, student, then you will get final product is, student, CH3 CH2I, right? Now here how many moles of HI is required, student? 5 moles of HI is required for this particular reaction. That is most important, student, right? Okay, now, right? So this is very, very important reaction, student. Just practice. I think there is no confusion, student. For that particular first, this will be 2 required HIs and second also 2 required. Then it will form a 1, 2 diiodoethane. It is the unstable and it is followed. If the I2 is a very good living group and form ethylene, then it is undergoing HI reaction. So therefore the 5 moles of HI is required. Now, okay, students, so we will practice some PYQ question of JEE Mains, student. Look at here. Advanced questions very less, student. Only maximum examiner is concentrating on this mains point of view, student. Now look at, student. So HI followed by the heating, student. Now, so we will get, student. Look at. So this is the step 1 process. Now look at. So he is asking only possible product, student, right? Now look at. This is I will use right now. This is also I will write now. This will be protonation of oxygen, right? Now, so I minus will attack. So usually, student, so this will be formed as a stable carbocation student, right? Now look at student, this will leave as methyl alcohol, then I minus will attack student, right? I minus will attack student, right? Followed by the SN1 mechanism. So then student, you will get the product is this is I, and again you will get this is, right? Now again look at student, again here I am using one more HI student, right? Similarly this will be converted into now this is I student, right? Now this will undergoes protonation, this will form, right? Now this I minus cannot attack student because it is not possible, right? Now look at student, this will be shift, right? Now your product will be this I minus will attack here, right? Now you will get the product to student. So this is the possible answer for this particular question student, right? Now this is the major product, right? Okay, now in this particular reaction, this is one, and what, right, byproducts we got student, one will be methyl alcohol from this one student, and one will be student ethyl iodide is the possible product. Okay, now right, now look at student, this is the 2019 question. HBr is given X student, right? So we will go for the individual step by step, right? First student, you can write this will be OCS3 is given, right? It is undergoing protonation, right? It is undergoing protonation, right? Now look at, so this will be given CH double bond CS3 is given, right? Simple student, right? Now Br minus is attacking, right? Now this is not possible student, so that's why it will be shifted. Now this will attack. Now you will get student, this will be alcohol, right? So phenol segment, and look at student, so this will be CH double bond CH3, right? Now again I have HBr student, right? So then it is followed by the electrophilic addition reaction student. It will followed by the electrophilic addition reaction student, right? Followed by the MR rule, Markovnikov rule, right? HBr is given, peroxide given, means we will follow the AMR rule, but here, so simply student, HBr excess is given, so now our product will be, this is the final major product to student. So you will get this Br will attack, and this will be student CH2 and CS3 student. This is the final product for this particular reaction, right? Next student, here also given excess of HBr is given, right? Now look at student, simple. So this will be formed as a step by step reaction we will discuss student. Now look at here. Now this will be formed as, this will be undergoing protonation of oxygen. Okay, now this is CH double bond CH2, right? Then so Br minus is attacking, right? This cleavage is not possible student, then so this bond will be shifted here. Now Br minus it attack, right? Now our product will be student, so our product will be, this will be OH, and this will be CH double bond CH2, and methyl bromide is the possible student, right? Now this reaction with again HBr student, right? So then it is followed by the electrophilic addition reaction student, right? Now you will get the possible product to student, right? This will be OH, and this will be CHBr, and CH3 is the possible product, right? Electrophilic addition student, this will be the most stable segment, the Br minus will attack here, right? Followed by the MR rule, right? Followed by the Markovnikov rule, right? Next student, this is the 2020 question student, right? This is also very beautiful question student, right? Here there is no issue with this segment student, right? There is no issue with this segment student. First this will form protonation student, this will be plus, and here, so this will be here student, this will be Cn, and this will be O, right? Now look at student, I minus will attack, excess is given, right? Now this side breaking is not possible, right? Now this is CH3, now this will attack student, so we will get the product student. This is the possible product, one will be OH, right? Byproduct will be CS3I, and look at student, so this will be the C, right? Now this will be, right, like this student. Okay, now right, now This is student. Now here only problem is there, student, right? Now student will get answer, sir, this will be OH is one answer, this will be the iodide part, or this will be iodide and this will be OH, right? Look at student, this is the benzylic position, student. So generally benzylic position means, student, it is followed by the SN1 mechanism. Simple, student, right? Now our product will be right. So options are given both, student, right? So but we will mark the answer is more appropriate answer. Now this is our possible product, and this will be, student, this will be the alcohol, right? One more product also I will write, student, that is also given in the option, but that is not our major product to, student, right? Now you can get this one, and one more option is given, student, this will be given as a, right, now, and one more option is given, student. So this is the possibility only, right? Okay, but major favorable product is, student, this one, because of, student, formation of a, right, and CN also is present, student, that stabilized by the carbocation also possible, then so SN1 mechanism is favorable here, right? Now look at, student, right? Now we will move to the 2020 question, student, right? Now look at HBr excess is given. HBr excess is given, student. So first we will get the A product is, student. This will be OH, I will write, student. OH I will write, student, right? So this is the possible product, and here also HBr excess is given, followed by the Markovnikov rule, student. Just I am writing the both possible, right? Now look at, student, this one Br will be attacked, student. Here I am not going directly, but here simple only, right? Now look at, student, so this Br will be attacked here. Now this will be CS3, student, right? Now look at, student, so this will be H, student, right? Now this Br minus will attack here, student, right? Now this is right, now this is right. Now HBr is there, student. Now this Br will attack, and here H will be attacked. Now this is right. Now this is our A product, student, right? Now this A undergoing, student, alcoholic KOH. Alcoholic KOH means, student, generally dehydrohalogenation takes place, right? Now if it is undergoing dehydrohalogenation, student, so generally this will be alpha beta elimination takes place, student. So generally you will get the product, student, this will be, I will keep OH as it is, student, right? Now this you will get double bond over here, right? You will get the double bond over here, right? Now again you will get the double bond over, student, right? Now this undergoing, this is our possible B product, student. Now this possible B, student, it is undergoing ozonolysis. This is the reductive ozonolysis, student, right? This is what, student? Reductive ozonolysis. This is not oxidative ozonolysis, right? Now this will be leave, student. This will add O, right? Now this bond breaking, add O, right? Now the possible product here I will write, student. The possible product here I will write, student. This is the one possible product, student, OH, and this will be CHO. Am I correct? Right? This is one possible, and here this will be CHO, this will be CHO. This is the glyoxal. Okay, right? Now this will be final product will be, student, HCHO. I hope these are the possible reactions, right? Okay, right? Now we will move to the one more question, student, right? Now look at, student, HBr reaction is present, same reaction, student, right? Now this will be, we will write the A, student, right? Now this will be, I will write, student, this is, I will write, this will be OH directly, student, right? Then this will write, so I will write, student, here only, this will be OH plus. Now this bond will break. Now this Br minus will attack here, right? Now this Br minus will attack. Now I will write, student. Now look at, student, this I will write like this. This will be 1 carbon, this is 2 carbon, 3 carbon, 1, 2, and this is 3rd carbon, student, right? Now look at, student, 1, 2, this will be CH2Br, right? 1, 2, right? Now look at, student, right? This will be CH2Br, right? Now look at, student, so 1, 2, this will be, right? Now look at, student, now this will be followed by sodium ether, student, right? So it is followed by the sodium ether, student. Generally it is followed by the Wurtz reaction only. It is followed by the Wurtz reaction, student. So generally it is 1,3. So it is followed by the cyclization only, right? It is followed by the cyclization only. This will form a free radical, and this will form a free radical, and free radical addition takes place. Now you will get the possible product, student. You will get the possible product. Now this will be OH is as it is, student, right? Now This is the possible product to student. Right now, the total number of carbon atom 4 only. Now 1, 2, 3, here 4. 1, 2, 3, 4. Right now, this is our possible product to student. Now we will move to the one more question. This is also 2020 question, student. Now HI is given, not X is given, student. That is the good thing. Right now, H will attack here. Right, H will attack here. So this will be the step 1 process, protonation of oxygen. Right, okay. Now I minus will attack. Right, I minus has two possibilities. It will attack here, it will attack here. Here more steric endurance is present. So that's why it is followed by the SN1, SN2 mechanism, less steric side. Right now, what? Right. The given question is one will be alcohol only. Ethyl iodide also we are getting, but is examiner given as alcohol is A. Right. Now I will write the product is, student. One will be CH3, CH2I. Right. Now our alcohol will be, this will be CH3, CH2, CH, CS3, and this will be CH2OH. Right. Now this undergoing, student, dehydration process. This undergoing, student, dehydration process. Right now, if it is undergoing dehydration process, we have two possibilities. Right now, H plus will come, H plus will come. Right, oxygen lone pair are present, same protonation of oxygen, student. Right now, so we will get the possible product to student. Now this will be CH3. Right now you will get a CH2 plus, student, because of loss of water molecule. Right now we are getting a 1 degree carbocation. Right, now we are getting a 1 degree carbocation, student. Right, that is not stable. If it is 1 degree carbocation formation takes place, then we will do the rearrangement to student. Right, so rearrangement process we will do right now. So rearrangement process we will do, student. Right now, if I do rearrangement of this, student, now for example this hydrogen is present. Right now, this hydrogen will be shifted here, student. So generally it will form a 3 degree carbocation. Now look at, student. So this will form a more stable 3 degree carbocation, student. Right now it is form a 3 degree carbocation. Now maybe you can ask, sir, we can shift the methyl group. Yes, you can do, but it will be a 2 degree carbocation. But if I do the migration of hydrogen, that will form a more stable carbocation than migration of methyl group. Right now, look at, student. So generally it is followed by the elimination. Right now this will be here I will write, student, hydrogen. Right now this will be formed. Right now we will get, student, this will be CH3, CH double bond, CH. So this will be CH3, student. Right now this is CH3, student. So this is the possible major product of particular B for the reaction, student. Right, I hope, I think you are following, student. Right now look at, student. So this is given as HI, student. Right, general reaction only, simple. This is the 2021 question, student. Right now look at, now this is the first reaction, student. OCS3, this will be plus, student. Right, this is the step 1 process. Then I minus will attack, this will form, this you will get, student. Now this is the possible product. Now this is the possible product. Simply we can call it is what, student? Alpha naphthol is the product. Right now this is the CS3 high. Right, very simple, student. Right now we will move to the 2022 question, student. Right now look at, now this is reacted with concentration of HI. Right now same process, student. So we will get the first possible product. Right now look at, student. So simple, student. So this will be OH. Right now look at, this will be, right now I minus is the possibility. Right now it cannot cleave here, so then you will get, student. So phenol. Right now this is our phenol. Right now, so most probably examiner concentration is, right, this one. Right, and byproduct will be this one, student. Right now this is undergoing zinc upon heating, student. So generally you will get the benzene is the possible product. Right, so phenol on reaction with zinc, student. So then byproduct will be Zn oxide. Okay, so this is about reaction, student. So PYQs of maximum I covered. Right now look at, just revise the notes, student. That is help you a lot. Right now, next segment, student, we will discuss the calculate number of moles of HI consumed in this reaction. Right now, how many moles of HI consumed? Right, first step. Now if I used 1 mole, student, if I used 1 mole, then what will happen, student? So this is the symmetrical ether. One I will get CH3OH and one I will get CH3I. Right. Now again this CH3OH reacted with one more HI. Then you will get student, right. Now look at student, how many moles of HI consumed here? 2 moles of HI is consumed in this reaction. Now look at student, right. Now this is, so one product will be student. So it is undergoing, this is OH student, right. Now this will be protonation, right. Now I minus will come student, right. I minus has only one possibility student, right. Now this will be right. Now this phenol again it cannot undergo any next further reaction student. The reaction stop here only, right. So there is no further HI reaction student. So therefore number of moles of HI reacted student required, only 1 mole of HI is required here. Now look at student, here also the same thing student, right. Now we have possibilities, we will write the possibilities. Now look at, so this will be OH plus, now this will be phenyl, right. Now I minus has, right. Now this side I cannot do anything student. Now this will be shifted, right. Now this will be comes here, right. Now I will get student. So one will be the phenol, one will be the phenol and one will be, right. Now this will be benzylic type of compound. This will be CH2I. So then again I cannot do any reaction with HI student, not possible. The number of moles of HI required here 1 only. The number of possible HI required student only 1, right. Now so we will do one more reaction student, reaction with this particular, right. Now look at student. First here this side is not possible student, here only possible, right. Now I will write student, so pH like this, this is I will write student. Now this will be OH student. So this will be pH3. Now again reaction with I minus student. Now this will be shift and this will attack student, right. Now we will get PHO, so PHOH student, right. Then CH3I student. So most probably only 1 mole of HI is required for this particular reaction, right. Now look at student, one more reaction. So how many moles of HI, right. Now so we will do student, first case is what student? So we will get this one will be OH plus CH3I. Now I required 1 mole, right. Again here I have one more OCS3 student. Again I reacted with one more HI. Then I will get student, this is also OH catechol. So now look at student, how many moles of HI required student? Here 1 mole, here 1 mole. So the total number of moles of OH required student, HI required student, 2 moles of HI required student. Next student, just look at here, right. So the possibilities, right. First I will break here. Now I will get, right. Now this is HI student, right. Now again student, this will be OH, this will be I. Now so now I used 2 moles student. Now I used 2 moles here, right. Now I used 2 moles. This will be OH and this will be OH student, right. Okay. Now this will be CH2I and this will be CH2I. Okay now, right. Now this is followed, this is unstable only student. This is unstable only. It lost I2 and it will form CH2 double bond CH2. Again it react with student one more HI and you will get student CH3 CH2I is the possible product. Now for this reaction student, for this reaction how many possibilities of HI required student? So 3 moles of HI is required here, right. Now look at the 7th question student. Now look at the 7th question, right. How many moles of HI, right. So this is student, first we will get student, this will be right. Now I will write student, this will be OH H plus student, right. OH H plus, right. Now I have 2 possibilities, right. Now if I leave the H2O, then this I minus will attack student, right. Now so I will write this will be as it is student OCH3. Now I used 1 mole student, right. Now I will get this will be like this student, this will be I. Okay, now this will be I, right. Next student, so I will keep this will be OCH3, right. So byproduct will be H2O. Now look at student, same again I am using one more HI, right. Now I will get the product student, I will get the product I will get the product, this will be I, and I will get, this will be CH2 OH plus HC, right? Now CH3, right? Now I have two possibilities, student. So usually benzylic position is present, student. Then I will follow the SN1 mechanism. Am I correct? Now this I minus, student, this will attack and you will get the CH3OH, right? Now I will get, student, I will get the possible product, this will be I and this will be I. Now I have methyl alcohol is left over. Now again it will reacted with HI, student, then it will form CH3I. Now this particular reaction, the number of moles of HI is required, student. 3 moles of HI is required for this particular. Now look at, student, one more example, right? Now same reaction, student, right? Now look at, student, right? Now this will be, right? Now this will be CH2, right? Now this is protonation, right? This is protonation of oxygen, this will be OCH3, right? Now I minus is present, followed by the SN1 mechanism, this will leave, I minus will attack, and you will get, this will be CH2I. Now we have, student, OCH3. Now again it will react to, student, HI again, right? Now look at, student, so you will get the product, student, this will be CH2I and this will be OH plus CH3I, student, right? Now these particular cases, student, how many moles of HI is required, student? So 2 moles of HI is required for this particular segment, student. Clear, student, right? Now this will be, again HI is not possible, student, because here we have only OCH3 only, right? Now this will be add here, student, this will be H2O, right? Now this will be CHOH, student, right? Now this will be possible product. Next, student, now this is one more, student. Now look at here, I will go to the directly, student, just you can understand, right? Now I will break here, student, I will break here. So generally most probably student will give the answer. Now this is possible, right? Now if it is forming a plus, student, that is not possible, student, right? That is not possible. Here you are breaking, here also phenyl plus is possible. So that's why this reaction is not feasible, student. The number of moles of HI is asking, student, then you can give the answer will be 0 only. Why? Because, student, both SN2 and SN1 not possible here, student. Okay, maybe student will think, sir, we will add OH, sir. Now this will be plus, this will be unstable only. Again I minus will not possible for attack either SN2 or SN1 mechanism. So that's why, student. Now look at, student, so this is glycerol reaction with HI. So he is asking number of moles of HI is required for this, right? Okay, so general, student, so this will be leave water molecule, here leave water molecule, so leave water molecule, leave water molecule. So here this is everybody knows, right? So from this case here it require, so 3 moles of HI. Okay, na, right? So now next, so this will be, student, unstable, this 1,2 position. So it will lose I2 and it will form CH2 double bond CH and CH2I. So this is allyl iodide. This is allyl iodide. This is allyl iodide, right? Now this allyl iodide reaction with HI, student, right? Now followed by the MR rule. So this is followed by the Markovnikov rule, followed by the Markovnikov rule. So this is electrophilic addition takes place, right? So this is the stable carbocation. So the I minus will attack here. Now you will get, student, this will be CHI and this will be CH2I, right? Again, so I2 is present, student, it is unstable, right? It lost I2, then it will form CH3 CH double bond CH2, right? Now again it react with HI, so then it will form, student, so this is a 2-iodopropane, right? Now for this reaction, student, how many moles of HI required? Here 3 mole, here 1 mole, here 1 mole. So the total number of moles required, student, 5 moles required, right? So this is about our ethers on reaction with HI, student, right? So this is very important lecture, student. So maximum you can follow, student. If benzoylic position is present, student, follow the SN1 mechanism. If the remaining cases, student, you can follow the reaction with HI followed by the SN2, right? Okay, this is the first point you remember. The second point you remember, student, if you have a symmetrical ether, student, maximum you will get the same type of product. If unsymmetrical ether is present, student, on reaction with HI, step 1 will be the protonation of oxygen, step 2 will be the, student, that I minus will attack, student, less hindered side only, when in case of what? Unsymmetrical ether, right? Okay, and if examiner is given as a excess of HI, student, so the final product will be, there is no issue, student, so generally the final product will be iodide only, right? These points are very, very important, student, right? I hope you, right, you like the video, right? So please subscribe my channel and like the video and share to your friends. Thank you very much, student.